Till now we didn't design. Okay, we were trying to understand what type of the design we can do and what are the things we should not do. We may have to do. We can do all those things. We understood. Now, approaches to the software design. Now, Lotus is a project. We want to go ahead with the design. Okay, let us see the approaches. Lotus this project you can design through functional oriented design or object oriented design. In your project, each one is getting the project right. We will ask you do however you want. No, we are not bothered. But I might ask your project is based on functional oriented design or object oriented. You may not have you wouldn't have designed or you may not be aware what you have done. But you should know your project adhering to which type of design factor. We'll come back to your project later. Now we'll go ahead with the theory part and come back again. Okay, for understanding. The two design approaches are radically different. They are complementary rather than competing techniques. It's not that that is better or this is better. For something is definitely required. For some other project, rest of the project should use one of the things. Which one is where? Let us see now. Okay. Now, first we are moving before function-oriented design, object-oriented design. Let us discuss. Understand, not discuss, understand. The features of the function-oriented design. See, now still I have not selected what is okay for Lotus. For Lotus, for a project, you can, if you're using function-oriented design, what are the types we are trying to understand? Top-down design. So here, each high-level function is successfully refined into more detailed function. Okay. Say, for example, consider the function create a new library member. Library member you want to create. What you will do? Assign a member number, create a membership card, print to the bill. So every member will get a membership number, create a membership card for the respective member, and print the bill over. That's all. New member is created. This is about top-down composition. Now, centralized system status. We'll see the second type in the object-oriented design. You all know Java, you have studied all object-oriented program. Everything is an object for us. Okay. Here the system state is centralized and centralized and shared among different functions. Okay, in the sense here also member record should be done. Create a new member, delete a member, update a member record. So here it will be single object. Library management system. Here I'm reading this point. Library management system, several functions such as following share the data such as member record. So member record means these three will be there. Create a new member, delete a member, update a member. This is about member record. Here new member means it will create a member record. So it will have all other types of inputs for respective new member. That is a function oriented. Now there is if you are adhering to object oriented design, then what it will be? Either you can take that to this approach. In the object oriented design approach, the system is viewed as being made up of a collection of objects. Each object is associated with a set of function that is called methods. Each object contains its own data, responsible managing it. The data internal to the object cannot be accessed direct by the object and only through the invocation methods of the object. Hope you understood this, isn't it? Same thing, no? In your programming you do. You create objects, but you can call the objects only through the methods. Directly you cannot communicate with the object. Call the object. So the state is decentralized. It's fully the system state is decentralized since there is no globally shared data in the system and data shared to the object. That is about object-oriented design. Now, difference between we try to understand about that and this. Now both we are comparing object-oriented and function-oriented. It is given, this is object-oriented, this is function-oriented corresponding. In object-oriented design, the basic abstraction are not real-world functions such as sort, display, track, etc. But real-world entities such as employee, picture, machine, like that we use. For example, object-oriented and employee payroll system is not developed using the functions such as update, employee record, etc. It will have the object, employee name, department, etc. You can read and understand. In function-oriented design, the functions are grouped. If grouped, the constitute higher level functions. On the other hand, here function basic data belongs to the particular person. So similarly, other details are explained. You people can go through about those two. Now, function-oriented software design. Now, little more about your design. See, so only teaching the various methodologies, types, where to use, where not to use, what are the advantages, disadvantages of examples are given until now. Now, function-oriented software design. This design technique use a system as a black box and provides a set of services to the users of the software. This is also high-level function during the design process of high-level functions are successfully decomposed into more detailed small functions. That's the feature. That is the feature of this methodology. Now, that is what here they are given. Now, here you can see structured analysis and structured design. See, the structured analysis, structured design techniques can be used to perform the high-level design of a software. Structured analysis and structured design methodology. What I'm trying to tell is here, we will just try to understand this diagram alone. Okay. See, here you can see the SRS. For the SRS, we can apply structural analysis methodology, which is explained down little line. For that, you'll get a data flow diagram. Okay, from that you will apply the structure design and you make a flow chart. Then you can code it, right? That with that it's ready for coding. So it's both are explained, you read and understand. Now I'm talking about structural analysis and structural design in detail here. Here both are defined. Functional decomposition, it is the okay, and it is a module structure. Here, structural analysis methodology, if you are heading. During the structured analysis, the major processing task, high-level design of the system are analyzed. Well, and the principle of the two techniques, top-down decomposition techniques and application of the divide and conquer principle or graphical user representation DFT. So that's here. No? They have explained here SA and DA, SD. Now data flow diagram, little bit we'll understand here. Data flow diagram is a hierarchical graphical model of a system that shows the different processing activities. Okay, data flow diagram, reading here. Data flow diagram model only represents the data flow aspects of the aspects, does not show the sequence of execution of the different functions and the conditions based on which function may or may not be executed. This is about the core function of data flow diagram. There are symbols are there, and external entry, process, output, data flow, data statistics. We may ask in your multiple choice question. Okay. Certain concepts are given, you just try to know synchronous data, and it's very, very simple to understand asynchronous data. There are two types, whichever is applicable. You can, as you said, that all is online, no, it is asynchronous is better. Synchronous is single sequence in your projects and all, you can use single sequence. Asynchronous means you won't have a coupling. Okay, you put the data, you take the data. You never ask him to give directly. That is, if a valid number, somebody is reading, somebody is validating. Instead of this, if you're directly waiting him to give, see, you will send acknowledgement, you will receive, you will confirm. So that's 3 transactions, right? So that is tightly coupled, or it is functionally coupled. The cohesion it is. You are putting the some other module or a database, you take it and take it forward the function. Okay, now something called every data flow diagram, something called that dictionary is there. If you are using the data flow diagram, dictionary is supposed to be there. So every data flow diagram model of a system must be accompanied with the data dictionary. Data dictionary is relevant to our project. Say in our case, we have to do the data flow diagram. If we are doing, if I'm not telling we are using, if we are adopting this design methodology, then we have to make a data dictionary for Lotus project. Here it is a data flow diagram. The dictionary importance is explained. You can read it, is self-understandable. You can read, okay? Only one diagram. Here I just take definition, no data. Here they say plus means A plus B represents either A or B. Then if it is put like this, comma, represent either A occurs or B occurs. If you put a bracket operation that like this, represent either A or A plus B occurs. So like that, now you make the representation and you continue in your design document where all can read and understand. Here we are trying to understand the shortcomings of the data flow diagram. In case if in your design you decide to go ahead with the data flow diagram, what are the shortcomings and disadvantages? It makes the programmers a little confusing. Bigger drawback is that it simply takes a long time to create. Creating takes a long time. Okay, so long that analysts may not receive support from the management to complete it. It takes creating takes a long time, but it's, we can decide which one to use it. Next, physical consideration left out. Yeah, fully outcome is like that. Certain drawbacks are given here. Now, SD structure design. You saw no in the main diagram. Structured analysis between SRS and data flow diagram, structured analysis there, and a little bit you understood about data flow diagram. Now, before actually structure chart or a flow chart, we need something called structure design. Let us see what it is. Oh, sorry, I have kept a diagram here also. The aim of structure design is to transform the results of structural analysis into structural chart. So structural design aim is to transfer structural analysis into structural chart. Structural chart represents can be implemented into some programming. Thereafter, coding starts. Once this is ready, the coding starts. In any structured chart, there should be one and only one module at the top called root. So there should be almost one control relationship between the two modules in the structure chart. Okay, they're talking about the structure chart. Of course, only one root and multiple clients. Then flow chart versus structural chart. Now they're trying to tell flow chart and structural chart. What is the difference? You may get the doubt which we are hearing first time. Then what is the meaning of flow chart and this? We'll read a little bit. It is usually different to identify the difference between. It is difficult to identify the difference between the program from its flow chart representation. See, the structure chart is more easier to understand than the flow chart. Data interchange among different modules is not represented in flow chart. Sequential ordering of a task and its inheritance flow chart is suppressed in essay. See, sequential ordering of a task that is inherent to the flow chart is suppressed in. Okay, this is only the drawback. Other rest of advantages. It's again, if your application is more data oriented, you take a decision. If it is more function oriented, you take a decision. See, anyway, we have to understand how to define or how to draw flow chart or how to draw structural chart. All those things we have. Only with small intro we cannot do, but small intro, if required, we can enhance our knowledge and take up the design. So, okay, next comes the detailed design, which I will not cover. Only thing is adjusted. That's what design. Now we'll only talk about a design review. Say I told no. We are adhering to software engineering practices. Means one of the primary method. Why do we adhere to software engineering practices? Because to develop a project with quality, okay, with same budget at same time. Okay, so in that process, review is one of the common metrics. That is the testing, any area, review is a common metric. So let us see now. The review team checks the design documentation for the following. So they see, assume, right? Let us assume Ankita has designed something. Okay, I supposed to review. How to review? Both should be knowledgeable. So what are the metrics? I have to see traceability is the one metric, correctness, maintainability, implementations. These are a few things I have to see and validate the design. Okay, now let us see. Lotus design is ready. Whichever methods we discuss a lot of things. Let us not go back and confuse ourselves. One method we have used and completed the design. Before taking up the coding, that should be reviewed and validated by somebody. The person who reviews has to check out traceability, whether each bubble of the DFT can be traced to the sum module of the structure chart. Like that, they have to see. They check whether each function required in the SRS document can be traced into the sum bubble in the data flow diagram model or vice versa. That means SRS you have to keep and make sure every aspect is covered in the data flow diagram and it are easily traceable also. Correctness. To identify the correct errors, inconsistency, omission. We should see whether they have corrected everything, any inconsistency there, anything left, we have to see. Maintainability, whether the design can be easily maintained in future. This also to be checked, which can check. I can give the example later in some context. Implementation, whether the design model can be implemented within the project constraints. That also they can validate because they will see whether how much it is network interlinked, coupled, whether so many modules are really required. Like that, we will be in a position to do the design review. Now I have come to the end. I just take up the summary. Is what a summary: a software design creates meaningful engineering representation of some software product that is to be built. See, I told no software product means it can be service, solution, anything. Then comes design model. Now, software requirement model is transferred into design model. So SRS is required. Each design product is reviewed for, just now we read now, for all these factors. So reference is what? IEEE standard 1016 is the design specification. Certain things are taken from there by all these practitioners. Fundamental software engineering 4th, the Rajiv Mal book is there. There we have taken April edition. Chapter 5 and 6 is referred to prepare these notes. Any questions, please?